Ladies and gentlemen, we had a request for a boiling point video from Winter 15, Test 1, Part 4. We're going to put the molecules in order of increasing boiling point. And I'm going to keep saying it over and over again. It's okay to use short forms, but you have to define them. I'm still going to see some people hand this test in, and they say, it says H bonding right there. Dr. Whitaker, I used HB. You never told me what HB stood for. You lost a quarter point. So if you are going to use these short forms to save time, so why don't you just, as a warm-up for the question, put your short forms at the top. HB means hydrogen bonding. You're telling me that. And then the next intermolecular force, DD. Dipole, dipole. And then we'll go LO. London only. And then we'll go heavy atoms, defined as CNO. That covers all of our organic stuff in red, okay? So I'll start with heavy atoms. 1, 2, 3, 4, 5, 6, 7. 5, 6, 7, 8. So if it was just size, I would take 2 over 1. It's more than just size, though. Bottom one, 3, 4, 5, 6, 7, 8. 8, got a lot of 8s. 1, 2, 3, 4, 5, 6, 7, 8. This seems typical, like it's like yours a lot. I tried to keep the sizes very similar. We did an example in the morning section where one of the molecules was a lot smaller. I didn't like it. It was like one too many variables. You'll see my displeasure on my own video. I wasn't happy with myself. And then we got 8 here. And 3, 4, 5, 6. Oh. And these are all LOs. Oh, that's not an LO. That's a DD. How come that's a DD there? This one here. Right here. It's got a carbonyl. That's an aldehyde. That is a polar covalent bond causing a permanent dipole-dipole. This is just hydrocarbon, right? No polar bonds at all. LO, 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 HB, it's got an OH. HB, it's got an NH. Ester has a carbonyl. It doesn't have an OH. So it's a DD. Do you want to tackle the H bonders first? Because they need to be over here in your answer. Hydrogen bonders of similar size will always have a higher boiling point than non-hydrogen bonders of a similar size, right? And which one of those HBs, we have 2 of them, has the best hydrogen bonding? It's not even close. 3.5 versus 3.0. What am I talking about? Electronegativities. The polarity of an OH is a lot higher than the polarity of an NH. So the hydrogen bonding is higher for 3 than it is for 2, and just say that. More extensive, now why don't we say, instead of more extensive, stronger HB, and tell me you know why. O, I'm trying to keep it short. I will accept this short form for electronegativity. What else could it be, right? And N. That's part of your explanation. So I'm comparing those two. That's why it's in green, okay? And then we want the DDs, okay? The DDs. One of these molecules has a DD, and it's just like a straight chain. We'll go with purple. 2, 4, 6, 8, 7. Sorry, 2, 4, 6, 7, 8. I got the number of carbons right. 1, 2, 3, 4, 5, and then yeah. And then the other one that's a DD, I will put here, and it goes. The fourth carbon is a carbonyl. 2, 4, to an O. It goes to a CH3. Now, which one looks more linear? Because they have the same forces, the same mass-ish. It's there was in like 2 AMUs. Same forces, same mass, but which one seems to be more linear? VI, yeah. VI is more linear, which means the molecules can get closer to each other. Is that going to help the forces or hurt them? Help. Yeah, they got to be close. So you're going to write this down as VI is a little better than, so VI is a little better than I. And you do that in purple. And you say, same forces, VI more linear D. Okay, why? I don't know. Higher BP. Higher BP. Same forces, VI more linear, higher BP because closer stacking. Stacking is when you put things on top of each other, right? What's that game where you stack things on top of each other? I forgot. It's a fun game. Never mind. Yeah, same for yeah. And then we got the hydrogen bonders done. We have the DDs done. Now let's look at London only. We got 3 London onlys. Why is VII top dog in that category? VII is top dog. Oops. Yeah. And then it's going to be IV. And then it's going to be V. And we're going to say VII is, of these 3, VII largest, London goes up, right? And then we go V and IV, same mass, comma, same forces, but IV is more branched. Do we agree? No, wait. No, sorry. V is more branched. IV is less branched is what I wanted to say. IV less branched. And we've already said it before, stacking up. I don't have to say the whole deal again, do I? That increases the stacking, better stacking. Okay, and I think that's close enough for everything. Not grading your grammar. Just tell me what separates things within the categories, okay?